Um, Hi everyone. Can you hear me? How's the sound quality? Okay, great. All right. So I suppose we can continue working on things, and we'll work in a similar manner as we did it all the time. So I will share the screen. We'll take a look on some materials. We'll try things on our computers. And that's the way how it will be going. Okay, so let's start with the screen sharing.
Good evening, sorry I'm late.
Yeah, good evening. It's not a problem. The most needed thing that you are connected, so everything's fine. All right, and the screen is available, so you'll place somewhere that small area that says me that everything is fine on my side. And let's go for things. Okay, well, I would like to remind you about things which has to be done. Um, so just try to find the time to make implementations in Python. And this time we will try to make a next step. I really hope this step will happen nicely today. So we'll make a first step in OOP, so object-oriented programming, in Python. Um, uh, Tell me, please, did you have any classes about just an OOP, maybe some theoretical classes, or maybe you use some another programming language like a Java or maybe C++? Um, what's the situation of your group?
Touched OOP maybe at school about 16, 18 years ago.
Okay, that makes sense. But what's about others? Mhm. Okay, fine. So what we'll be doing? We'll try to understand what is the object-oriented programming. Especially, we'll try to implement it in the Python because our time is quite limited, and we spend only some 60 minutes a week, so we have to do that in a very concentrated way. But anyways, I hope we'll manage this. Okay, so object-oriented programming. Literally, what's that? Actually, it's a sort of meanings which can be inherited and fulfilled. Um, so uh, to make a story easier, you can imagine that you have several groups of objects. So, for example, you have a group of objects called transports. In a transports, you have separation between planes, trains, cars, motorcycles, and any others. And then you make a split, so-called object hierarchical split. So you choose cars, and then you can have four wheels cars. Then you can have three wheels cars, which are quite famous in some Asian countries, and so on and so on. And then you make a split of them. So literally, you can say that each of those groups in the hierarchy have some characteristics. So, for example, four-wheel cars. Well, amount of cars equal to four, like three-wheel cars. So amount of wheels is equal to three, right? And then when we have a car and the car is being split, we have split in four-wheel cars, three-wheel cars. The car itself has some parameters. And going into hierarchy from the top to the bottom, we collect a bunch of parameters. And for each of the nodes in that hierarchy, we can say, okay, we can describe that by parameters starting from that object going up in the hierarchy. And literally, that's the main way how we can understand an object-oriented things. But okay, it's very simple how to say just telling this, but we will try to make implementation, and we'll try to get how that works, and we'll start with really basic things today. So next time there will be probably OOP2 presentation. Let's see. And we have to maybe start with one interesting thing. Well, one thing which should be kind of reminded, because we've worked quite nicely with some libraries. We try to use some maybe regex libraries, some maybe Pillow library to work with images. We try to use a Tkinter library to work with GUI, and so on. But what's inside them in reality? So inside those files which were important into our modules, there's some functions and there are some classes. For example, if we would have whatever file, for example, lib.py, let's suppose we can make this library in our files, and we can import them. So here we could have, for example, such things. So what do we have? We have a function, we have a function name, we have the argument, and we give back a text hello, and then name which is given as the argument. Okay, for example, definition of value which is greater than the argument. Okay, and surely in this case it's natural number, so integer. So literally we have I, and we give a value which is one step bigger and than I. Okay, so that's clear. So we have it. Next then, how do we make an import of that? And as you remember, we could make that in a different ways when we worked with regex, when we worked with the Pillow, and when we work with the Tkinter, especially with the Tkinter when we import Tkinter itself and the message box. You remember that they were two different imports. And right now it's the time when we are about to talk about this, because when we work with classes, when we work with the OOP, object-oriented programming, so we are mostly about to use external files. It's not mandatory, but mostly it's done in such way. So import lib. It means that everything which is stored in the lib file will be imported. And to make a reference to something that's important in that file, we have to use a name of this file, and then given a dot, and then only after that we are mentioning some maybe variables or functions or whatever elements there. And literally that's the way how we can access to those things, literally in a similar way as we used Tkinter. Maybe you remember that. So we write Tkinter, and then we just write something from that Tkinter library. Okay, well, sometimes we have such imports that says us that from the specific file we importing things, and we importing quite specific things, and then these specific things are imported besides the library itself. So it means the library is not imported, but from that library only one function is imported, or a definition of the class maybe. So here we have it, and literally we can use that. And since there is no library which is not imported, right? So we are making the reference for that imported element using that imported element's name. Like if we have a function f, then we just write the function f. Maybe you remember that previously I said that in the Python we have everything stored in files, and literally we have a lot of big libraries. So how can we get that it's really so? We can go for the Python, and for example, I will try to open. Oh, okay. I opened incorrect thing. So Python. then the right mouse click and open file location. Okay, I have the references here. Okay, so maybe I can go for a specific folder. So here I have one, and let's see what do we have in that installation. Okay, so as you can see, we have tons of files here, and we can have even different libraries. Well, for example, our already known Tkinter, right? So Tkinter is literally the folder in which we have a lot of different functions. Well, okay, not really functions, but actually definitions of so-called classes. Well, we will understand what's the meaning of the class. So literally here we can have a lot of different things. For example, the message box, which we used with you previously. If we would try to open that, maybe in Notepad++, we would find out that here we have a lot of variables. So, we have something predefined, in other words, and we can just use those variables, not the values, and we can have some functions over there, and so on and so on. Literally, that's the content of a lot of files, and that's the general structure of such files, and all of them are constructed in such manner. So that's how it works. Okay, so let's try to talk a bit about what's the class. So when we talk about objects, and once again we can remind the same hierarchy as I said previously. So cars, three-wheel cars, four-wheel cars, and so on and so on. The same can be even used, for example, for a person. Because let's say the person is the person, so person can have some maybe name, surname, mid-name, gender, and something else. But the person can do and person can do something, so we can make a lot of functions like maybe going somewhere, go head, back, left, right, and so on and so on. And based on some additional maybe entitlements of the person, we can give another functionalities or additional personalities to additional functionalities to a specific person. Literally in the similar manner as we had in the example of cars. So how is it possible to make a definition? And in this case, we will write a definition, which is something similar to a definition of the function. So previously we defined the function, and only afterwards we run that, given parameters of the function. So I hope you remember this. So here it's something similar. The only thing functions become and functions and variables become as components of let's call it a container that contains this, and we can call that as the class. So literally the class is kind of scheme by which we can create the object. So literally it contains, okay, we can call that as the recipe by which we can create some dish, for example. So we can say that a class is the recipe, and when we use the recipe, we receive a dish, right? So class is a definition, like a recipe that says us what ingredients we have, how we should cook, and so on and so on. And when we use that, then we have a dish. From the programming point of view, it's a recipe of what information, what action should be inside the object, and when we apply that, we receive the object. Literally, that's the story. What is the class? And inside that, we can have some variables, some functions, and a lot of other interesting things. Well, I really hope that this definition is more or less clear, at least from my perspective. From my, well, in my opinion, it's It's a really simple one, so I suppose it will be understandable. And for sure, we can put a definition of the person, in this case, in the file, which will have identical name as the name of the class. And for sure, extension will be PI for the Python. Okay, well, what do we have here? Here we have several functions which we can have. And here there is one interesting thing. Inside these classes, when we define a function, we have to give a reference to the self of the object. So it means that when we run the function, we run the function from the object. So it means that a reference to the object itself should be used there. But in reality, when we will give a list of parameters, or let's call it list of arguments, when we run the function, we don't really need to mention this reference called self. So it just must be, and I highlight must be, as the first argument of each function inside the class. And when we are referencing to elements, to variables of the class inside its definition, before those names, we have to place self and point. Just to say that, well, we are referencing to this name as a variable of the class person. And this name, since it's not a reference to the object itself, will come from the argument. Does it make sense, guys? So okay, we have 1 plus. Guys, if something is not really clear, you can always put a minus in the chat when I'm asking if everything's fine, because I have to know if you got this or you didn't. So please don't be shy. Okay. So, so as you can see here, we have several examples of how we can create the object from the person, or in other words, when we have example of, let's say, recipes. So we have a dish and the dish is created by the recipe, or we have a certain person which has a specific list of registered actions and variables. So how do we run functions from this object? We mention the name of the object, point, and then the name of the function, or maybe variable if we are accessing the variable. And then in the arguments, as you can see, we are not we don't really have this self. We just have all the rest of arguments here. Well, and all the rest here is just a name, and all the rest for a set job would be a job, and all the rest for describe would be none of arguments, because you see there is only one self and nothing after the self. So nothing is even mentioned here, but we have to use brackets, to give a list of arguments. Even if list is empty, doesn't matter. Okay, so okay, well, literally here you have the same things which I already described you. So anyways, this slide could be kind of a small helper for you afterwards. Well, here we have totally the same as already we talked about with you. And the other interesting thing which I would like to highlight is that sometimes we can have functions with the same name but with the different amount of arguments. So those functions are called overloaded functions, and the interesting thing is that we can always run the one or another function, but the most interesting thing that it's up to us which one of them will be run, But if we make, for example, some modification of the, let's say, Python, that basically would say us that it's not mandatory to mention some of arguments, they will become like a zero reference or a null or a zero, then such approach wouldn't be welcomed, because compiler, or let's call it interpreter, will never know which of these two of several functions will need to be used. Here, for example, here we have the case when we have a function set name and function get name. So it's kind of very interesting. So why do we have these things? Why? And for example, you can ask, why wouldn't we have, let's suppose, only a variable? So when you work only with variable, we can quite fully assign some values or read some values from the variable. In most of the cases, it's assumed as the really bad. And just to make a controlling of accessing the values, maybe modifying the values. It's not like we have to create the functions, but it's really welcomed solution. So for example, we rewriting the value, and here we just given back a value. Okay, so probably it's kind of known thing, and I suppose you already took a look maybe on some other programming languages as well. In most of the cases, since we have some variables and we define them, we always have something like initial values of them, right? So, which means that there is something that sets up the value. For example, if we would have some variable, well, let's say some integer variable, and I'm just mentioning things not from the Python, but from another languages, which is quite common actually for all programming languages. So if we have some variable, and let's suppose we're not defining its value, so somehow it happens that that variable has the value. Well, why? Because there is a mechanism to do that, and this mechanism mostly is called as constructor. And constructor is the function or a functionality which is being run once you create something. In our case, in case of the classes, that's the object made by the class, by the information of the class. So you can see that make p equal to person, we have brackets. Well, why? Because the definition of a class literally says us that the class actually is a super how to name that, is a super modified function in reality that gives back some object. That's the meaning of the class. That's the technical meaning of the class, which is not really necessary for you to remember. So that's why in the end of execution of the class main functions, if we can say like that, we have to use this list of arguments. And theoretically, you can ask, okay, if that's the function, is there any way to set up an initial value? And I would definitely say yes, there is such way. So, and this way is called constructor, as we talked previously. And it's not really necessary to, well, for the constructor to be just, registered as the default one. We can even make our own constructors of each class. For example, a function init. So, about the function init, as you can see, it has two underlines from both sides. So there should be exactly two of them. Literally, once again, we have the self as the first argument, and then we can have, or we cannot to have, a list of arguments. And as you can see, we have list of arguments contain only one, well, besides self, and we're using that. So once the person will be executed, we will need to give a value. We'll need to give the name, and that name will be used um, in a way that it will be saved in the name of the object. That's the idea. Yeah, and literally don't forget about a reference self all the time. Okay, so literally that's the story. For example, let's take a look at what we could do. Well, we could create the person with some constructor, and for the inside the constructor we'll give one of values, for example the name, and since there is just a name and object of the person class was just created, so there is not yet defined a job and the location, so we let's say can assign the values of unknown textually. And such class could have several functions that could literally show us some data. Okay, so maybe we can try at least to do something. So let's maybe copy these things. And let's suppose we will try to, the main will try to make everything inside the one file. Because well, actually, it surely depends on the compiler, but I think that this compiler should allow us to store everything in one file. Okay, so we have it. Then we will use the following. So p will be equal to person. Let's give some data. John, it doesn't really matter. And what we can do, we can print, for example, a name of the person. Oh, let's say like that. Okay, let's try to run it through the Python. So I will take this this path, and I will go for a CMD. So I will use the command prompt, and I will go to that folder, and I'm about to run b.py file. Okay, what do we have here? Okay, so something's not great. So probably because I'm trying to access a definition. Yes, because I didn't give any arguments. Yes. Okay, so let's try to run it. Okay, so as you can see, we just get the access to the name. Okay, awesome. Let's suppose we'll try to have an access to a job and location, right? And as you can see, we get to have unknown in both of them. Let's see how that works. Yeah, so we have John and we have two unknowns for the job and location. Literally, that's the way how that looks like. And you know, I will maybe copy this code so you could try this on your computers, on your machines. So maybe try this and maybe put a plus if it happened, if everything works well. Great. So Wide is finished. Okay, and let's wait for others as well. Because it would be really, really nice if you would manage to do that. Okay, so Evgeny made that. Okay, great. Okay, and what's about Nikita, Ras, and Thomas? Okay, let's wait a half minute and then continue.
Trying to put tabs in the right places.
Okay, that's the struggle of the Python. I know this, I know this. Okay, let's wait a bit. Okay, so Rasa did that. Okay, great. So let's wait for Thomas and Nikita. Okay, Thomas made that. And let's wait a few seconds for Nikita. Okay, that's awesome. So everyone made that. Okay, everyone, but okay, you're only 5 today. All right. Okay, so let's overlook another things. So let's scroll forward. Okay, so surely there are a few differences. Actually, not really few, but some differences between the Python object-oriented programming itself and um, and uh, and the and the only the general meaning of object-oriented programming. Well, why? Because in the Python we don't really have variables which are not defined. So that makes the small differences between what you can find out on the internet based on object-oriented programming and what you will get while you will be programming. Okay, well, what's the interesting? The most interesting things is that how do we store this data? How do we maybe access them in real applications? Surely it's well, if the definition of the class is not in the same file in which we are working, then in most of the cases we are having that file which will be imported. It's clear. It has to happen. And then in the best case scenario, we have something like a collection, maybe a set. In most of the cases, is the set, not the tuple. And we make a variable, literally, that has the reference to the object, and we assign that reference into the collection. And the same happens for every of objects. And this is a so-called quite general approach. So literally you can use it, and you can just go through all of these objects and you can somehow analyze them, for example. Okay. So there could be an interesting question. So let's suppose we assign them to an array. In most of the cases, we would say, okay, so if we have them in the array, then we can work with those objects only from the array. But if you remember what I said some classes ago when we took a look on collections, especially maybe you remember that's related to arrays, we cannot really assign one array to another array directly. Well, why? Because actually the array is a specific reference to the memory cell, and and the array has its own well, how to say, a scheme size, which will be used starting from that address, which is referenced into and forward in the addresses, and that the portion of addresses, portion of memory, let's call that this way, will be used as an array. Here is the same. Every object we have here, Bill and Claire, they're just references. So when we make an object, we are literally operating with some memory, with some cell of the memory, and we give the address to that portion of the memory, to the first byte of that memory, to these variables. And then, so once again, it's just an address in the memory, nothing else. It's not the object itself. So here we give that address, and here we give that address. So literally, right now, the first element of array people and Bill and the reference Bill literally operate the same region in the memory. And that happens for the Bill and the first element of the people, and the same will work with the clear and the second argument of the people. Sorry, second element of the people. That's the way how it works. And so literally, once again, you have to keep this in mind all the time. For example, if you wouldn't need such references, you can just create some reference, for example, Bill, then you create the Bill person, then you assign it to the people, then you would write again Bill, then there would be a person clear, and you would add another reference, and in the end you would just assign some null or a zero to the Bill variable, and that would be fine. So you wouldn't have such variables. Okay. So so after adding so literally here we have the same thing as I just described you. So I suppose this one is clear. We have memory, we have variables, we have array that operates with that memory. So it is what it is. It is the way of working with that. So what can we say about the classes? What can we say about some maybe tries to create some such schemes of data? Well, those classes could be quite different. Unfortunately, we cannot all the time we cannot access data when it's not assigned, unfortunately, here. So that would be a thing which would be different in OOP documentations and descriptions for Python and the general ones. And for sure we can collect objects into some collections, let's say a list, or actually it could be even a tuple if we like. And maybe you remember the third collection is the text, which is not applicable for this thing. Okay, so I suppose more or less idea is clear. Okay, so we have some 20 minutes left. That's 20 if I'm not mistaken. Yes, 20 minutes left. So probably I would like to ask you guys to implement one thing and share your results, because it's interesting how you will make that. So your task will be well, let's say to create let's say something like the address book of the phone. So maybe there could be several names, several fields of the person, like a first name, a last name, phone number, and then I would maybe ask you to make a sorting of it, for example, using the bubble sort. Everyone knows the bubble sort, right? Oh no. Okay. Okay, so in this case, just make an array, just create the class and try to fill the array with contacts. Okay, so that would be quite enough. By the way, guys, did you have any classes related to sorting algorithms? How to sort information in arrays? Like there was regular sort and bubble sort, so-called stone sort, horse sort, and others. Okay, I see. So maybe next time we'll take a look on that because it's really necessary topic in programming. Okay, guys. So I suppose the task for now is clear. So please try to make this address book and share your codes when you will finish. And let's say you will have maybe some maybe 10 minutes for that. So what's your progress, guys? Okay, maybe it means that you have to have more minutes. Okay. All right, we have a few minutes until the end. So why wouldn't you share your results? What you have so far? Okay, I see. I see. All right. Okay, well, we still have a bit of time, so maybe I can show you how you can make these things in a really fast way. So let's once again go to Windows. Oh, okay, I see that Thomas writing something.
I don't know if this is good. It's just simple, very simple.
Okay. Okay. It's not what was expected. Yeah, it's not what was expected. Because we're talking about objects based on the classes, right? So it's
Oh, okay.
all right. All right. So let me show you what was the idea. So I will just use my already created code which I shared with you, and we have there some maybe name, surname, maybe no idea, phone number, um, like this, right? And we can say, okay, we'll have some name, surname, phone number. So this will come from a variable as that is the surname. This will be the phone number, right? And we can actually make even some functions like get surname that gives back the surname, get phone that gives back the phone. So like this. And surely it means that we have to give some values like this. Okay, it's not really good, but let's suppose it will be this one. Okay, and what we can do, we can literally have some array. So let's call it data. That's the list literally, and we're saying okay, we have this element, and then we will use a data append. So literally we are pulling a person inside this array. That's it. That's really awesome. And what we are doing, we just repeating that a few times. So for example, we have let's say one person. Okay, I will just put some numbers without thinking about some different names. We just don't have time for that, like this, like this one. And then in the end you can just zero the p-value like this. So p wouldn't be a reference anymore to some address. Well, that's the idea. And for sure you can run this like this. And if you would like to for example print the array, it wouldn't happen in a similar manner as as it happens for a regular thing. It will just give you some references, as you can see. So, but anyways, guys, what you can do, you can literally pick whatever index of this array afterwards, and you can just use oops, you can use whatever function we defined previously, like this one. Okay, so you will get the surname of the element with the index 1. Okay, let's see if that works. Yeah, so you see it works. And that's the way how you can do that. Just in case, I will copy you this code so you could have it, so you could take it, just in case if it's needed. Okay, I see that Evgeny sent the code, but it's not working. A code written. Well, why F? What's the F? You don't have the F in the list of arguments. Where the F? Where the L comes from? There is just N. That's it. Well, I hope it's clear where you have the problem. So you have to mention variables here. Well, not variables, but let's call it arguments of functions. Well, that's the idea. So, Evgeny, is it clear for you where you have the problem? Okay, great. All right, guys. So I see that it's the time to finish our class. So next time we'll continue working on things. Oh no, we have to take a look on certain algorithms. It's really necessary. So next time we'll take a look on certain algorithms. Maybe we'll sort some arrays with objects, and then we'll take and then we'll have a presentation about more advanced things from the OOP, because we have inheritance that should be overlooked as well, and it's very interesting and very needed to be overlooked. Okay, guys. So thanks for connecting today. Keep working on assignments, and next time we will continue overlooking really needed things. Okay, guys, so thanks again and see you next time. Have a nice evening, guys.
Thank you for the lecture. Bye bye.